Assalamualaikum. Hi guys. In the previous video, we learned how to determine the specific values for 4 different quantum numbers. So we learned there are principal quantum number, angular momentum quantum number, magnetic quantum number, and electron spin quantum number. But what is the use of these 4 quantum numbers that we've learned so far, and why we learn about them, and how you want to combine 4 of them together? So in order for you to understand that, you have to know, based on the previous subtopic, we cannot determine the exact position of electron, but we can understand based on orbital. There is a high probability of finding an electron in 3-dimensional space of orbital. So orbital can have different energy and size, can have different shape, can have different orientation, and can have different spin. So that's why these 4 quantum numbers are very, very important and related to one another to determine the position for one electron. So in order for you to determine a set of quantum number, you have to relate all of these 4 quantum numbers together. So how you want to write a set of quantum number? So I'm going to introduce one acronym to you, nasi lemak masak sambal. So nasi lemak masak sambal, we are going to take the first letter for each term to get in bracket nasi lemak masak sambal. Please make sure you put the bracket here. So let's do one example. If I have first energy level when n equals to 1, so my L value depends on n, should be less than n. So L value is 1 only, which is 0. So based on L value we can determine the shape of orbitals, which is s orbital. So s orbital can only have one orientation for m, which is 0. Because you shouldn't put positive 0 or negative 0, just put 0. That's why only one orientation for magnetic quantum number. Next, the last quantum number, electron spin, you can have in 2 different directions. So you have positive half, negative half. So how you want to write a set of quantum numbers based on this value? I'm going to write down my first one, this term, nasi lemak masak sambal, NLMS, equals to, we are going to have the value based on this one. So I got 1 for n, 0, 0, 0, 0, and positive half. But we got another one more, which is negative half. You can write it down as or another set of quantum number. So how many set of quantum numbers you have here? You got 2. This is 1 and this is 1. 2 sets. So a set of quantum number illustrate for one electron. And as I mentioned before, one orbital can hold maximum 2 electrons. So it's supposed to have, for s orbital, 2 electrons, because only one orientation here. So that's why you have 2 sets of quantum number. Let's try one example where you have to state whether each of the following symbol is acceptable designation for atomic orbital or not. If it's wrong, you have to explain what is the reason. So we have here 2D. So let's see. We have 2D. The number 2 here at the front indicates n equals to 2, the principal quantum number. And then you have d orbital. D orbital, you have a specific value for L equals to 2. So when you want to determine whether this one is acceptable or not, you have to make sure L must be less than n. So here L is 2, but N is 2. So this is unacceptable. Why? Because when N equals to 2, the allowed values for L should be 0 and 1 only. Hence, you will have only 2s and 2p orbital exist for second energy level. There is no 2d at all. So that is how you want to explain whether that orbital designation here is acceptable or not, or is allowed or not. Let's go second example. I have 6g. When n equals to 6, your L value is 4 based on g. So how do I know it is 4? Please remember, I mentioned to you you have to memorize the term for orbital starting from S, P, D, F. And S brings the value L equals to 0, P is 1, D is 2, F is 3. However, after F, when you follow the alphabetical order, it will be G, H, I, J, K, and so on. So the value should be increases 4, 5, 6, 7, 8, and so on. So that is how you want to determine the L value based on specific orbital. So let's get back to question B. You have n equals to 6 and g for the value L equals to 4 from here. So can you accept this value? Yes, because L is less than n. So this is acceptable. Next, we have another example, 7s, where 7 is n value and s brings the value L equals to 0. So the L value here, 0 is less than 7, so it is also acceptable. Last one, we have 5i. So when n equals to 5, your I value here is for L equals to 6. 6 is greater than 5. So this is unacceptable. So explain a bit. When n equals to 5, only the allowed values for L is 0, 1, 2, 3, 4. So you can only have these 5 orbitals for n equals to 5. So you can see there is no 5i based on this example. So that is why 5i is unacceptable orbital designation for n equals to 5. So I hope all of you learned a lot from this part. So that's it for now. I'll see you in the next one.